Ladies and gentlemen, this video is going to tell you how to plan, conduct, and communicate an investigation, or basically how to write a lab report, or what I expect from you in a lab report for a science lab or a science investigation. Throughout the year, you're going to be writing several lab reports on basically experiments that you do. We won't do a lab report on every experiment, but there are going to be a few throughout the year that you will have to write a full lab report for. If you've had me before for science in 6th or 7th grade, then you pretty much already know how I want you to write a lab report. This is basically just a refresher video to make sure that you remember all the pieces. So watch the video, take some notes, and just kind of jot down a couple notes here and there, and you're good to go. If you've never had me before, or if you did not do science fair last year with Mr. Espy, then this is going to be completely new to you, and you need to make sure that you're paying very close attention and taking very good notes. I will leave this video up on my YouTube channel throughout the year, so as you're going through and you're writing lab reports, if you get stuck or you forget something that I've said, you can come back and rewatch parts of the video if you need to. As we go through here, again, I'm going to show you how I want you to write a lab report. And to do that, we're going to use a sample experiment. Okay? And the sample experiment, or the example, is going to be a rotocopter experiment. If you don't know what a rotocopter is, a rotocopter basically is a paper helicopter. You make it out of paper. And the experiment we're going to do as a sample or an example is if I change the paper that the rotocopter is made out of. If I make one out of printer paper, one out of construction paper, and one out of tissue paper, which one will stay in the air the longest? So which one's the best one to use? Okay? So that's the sample we're going to go through. So at the bottom of each section, you'll see the example, and the example is based on that experiment. When you turn in your lab report, guys, of course, you're going to write yours about whatever experiment you're doing. Okay, the rotocopter experiment is just an example, so you can kind of see how it looks. So what do you have to have in a lab report? Well, first, you have to have a title. Your title should be at the top of the lab report, and it must go along with your experiment. It must actually relate to your experiment. Remember to capitalize the first letter of every word or every major word in a title, because all titles are capitalized. And again, it should be at the top of your paper. So in our example, my title would be The Best Materials for Making a Rotocopter. That's the title for my experiment. After the title, you need to have a question. Most of the time, guys, I will give you the question, but if you come up with your own, you need to make sure that first it's testable. It's something you can test. Second, you need to make sure that you have all the resources or materials you need to be able to test the question. Also, you need to make sure that your question is not a question that can be answered with the words yes or no. Okay, so it should not be a yes or no question. When you write down your question, or if I've given you a question when you go to write it down, you're going to basically put the word question at the top, left-hand corner of the page on the left-hand side, and underline it, and then write the question underneath. So here is my question for the rotocopter experiment is, what material will cause a rotocopter to stay in the air the longest? Because remember, I want to know, is it construction paper, is it printer paper, or is it tissue paper? After your question, you need to have a hypothesis. If you don't know, a hypothesis is basically just an educated guess or a prediction that answers your question. Okay? So you're going to make an educated guess as to what the answer to the question for the lab is. Okay? Your hypothesis must be something you can test. Okay? And you're going to write the word hypothesis on the left-hand side of your paper and underline it, and then you'll write down your hypothesis. Your hypothesis is going to have three main parts. First, it's going to have the word if. Okay? Then after the word if, you're going to tell what your independent variable is. If you don't know, your independent variable is the thing that you are changing. It's not the thing that just changes as you're doing the experiment because you're doing the experiment. It's the thing that you actually are going to change during the experiment yourself. Okay? After the word if and the independent variable, then you're going to put the word then, and you're going to put down the dependent variable. The dependent variable is the thing that you're measuring or observing in the experiment. It's going to be your results. Then you're going to use the word because and tell your reason why. Your reason why has to be an educated reason why, guys. It has to be a good reason why. It can't just be something you came up with on the fly. It should be something you've really thought about, and scientifically, this is your reason why you think what you think. So let me give you an example. For our rotocopter experiment, remember I'm using three different types of paper to build the rotocopter. So I say that's the thing that I'm changing, so that's the independent variable, it's the type of paper. Excuse me. And so I say if I use printer paper, tissue paper, and construction paper to make a rotocopter, then I'm going to put down what I'm measuring. I'm measuring how long the rotocopter will stay in the air. So I say then the printer paper will keep the rotocopter in the air the longest. And then I use the word because, and my reason why is because I think the printer paper will be just the perfect weight. It's not going to be too light or too heavy. So if I change the paper, then the printer paper will keep the rotocopter in the air the longest because it's not too light or too heavy. If you get stuck writing a hypothesis during your lab, please come see me. I will be happy to read it before you turn it in, or before you even do the lab, I'll read it, and I will help you with it if you need help writing it. After your hypothesis, you're going to list your variables under the variables section. And there's three types of variables you have to list. Again, you have to list the independent variable. That's the thing that you personally are changing during the experiment. You have to list the dependent variable. That's the thing you're measuring or you're observing. It's the results of your experiment. And then you have to list at least 3 control variables. Control variables, guys, are things that you're going to keep the same throughout the whole experiment. So for instance, during my rotocopter experiment, I'm changing the type of paper. So that means I'm not going to change the design of the rotocopter. I'm not going to change the type of paper clips I put on them. I'm not going to change the timer I'm using. I'm not going to change the height I'm dropping the rotocopter from. I'm not going to change the weather that I'm testing the rotocopters in. All of those other things are going to stay exactly the same throughout my whole experiment. The only thing I'm changing is the paper. Guys, when you do an experiment, this is super important. You can only change one thing during your experiment. You should have one independent variable or one thing you're changing for every experiment, and that's it. The reason why is if you change more than one thing, you have no way of knowing why you got the results you got. For instance, in our rotocopter experiment, let's say I changed the type of paper and I changed the height I dropped the rotocopter from. So let's say I dropped the construction paper rotocopters from 5 feet and the printer paper rotocopters from 10 feet and the tissue paper rotocopters from 7 feet. When I get my results of how long they stayed in the air, I have no idea whether or not it was actually the paper that made one stay in the air longer, or if it was because I dropped it from a higher height or a different height. That would not be a good experiment because I've changed more than one thing. I've changed 2 things. I've changed the height and the type of paper. So make sure you're only changing one thing in an experiment, and that way you know that your results are valid and that they're caused by only that one thing. Okay. So down here's my example. This is how you would write it. You'd write variables across the top left-hand side of your paper, underline it. Then you'd write independent variable equals, and in my case, I'm changing the type of paper for the rotocopter. Then you write dependent variable equals and tell how long, and what I'm measuring in this experiment is how long the rotocopter is staying in the air. And then I'm listing my 3 control variables. They are the design of the rotocopter, the height it is dropped from, and the timer being used to time it. Again, guys, you may have more than 3 control variables, but you only have to list 3 of them for your experiment. After your variables, you need to list your materials. You need to list everything that you're going to use in the experiment and make sure you give the quantities for each material. You're going to put it under the title material. So again, in my example, I'm using 1 piece of printer paper, 1 piece of construction paper, 1 paper clip, 1 pair of scissors, 1 rotocopter template, 1 piece of tissue paper, and 1 stopwatch. Okay? Notice I didn't just say I'm using printer paper. I didn't just say I'm using construction paper. I gave a quantity. So you're going to want to make sure you give the quantity for each thing. Once you're finished with the materials, you're going to basically write out your procedures. Your procedures are a list of steps or instructions for how you're doing the experiment. Your procedures need to be super detailed. They need to be detailed enough that somebody else can pick up your report, your lab report, and actually go do the experiment based on what you've written. Okay? All of your procedures should start with a verb, okay, an action word. The steps need to be numbered And guys, this is the big one, and this is the one that people struggle with so much. Your procedures should contain no personal pronouns. You cannot use the words I, he, she, we, us, you, our, your, or it. And again, don't use the word it in your procedures. No personal pronouns. Guys, when you write your procedures, go back and double check for this last one, because this is the #1 mistake that most kids make. They end up putting some of these in there and they cannot be in there. Okay? So here's my example for the rotocopter experiment for my procedures. Step 1, I'm going to make 1 rotocopter out of printer paper using the template. Step 2, I'm going to make 1 rotocopter out of construction paper using the template. Step 3, I'm going to make 1 rotocopter out of tissue paper using the template. Step 4, I'm going to place a paper clip at the bottom of each rotocopter. Step 5, I'm going to drop each rotocopter from 5 feet and time how long the rotocopter takes to hit the ground. Step 6, I'm going to record the time. And step 7, I'm going to repeat steps 5 and 6 3 times for each rotocopter. Notice in here all of my procedures are numbered. They're very detailed. They all have verbs or start with a verb, and there's no personal pronouns in here. Notice that nowhere in here is the word it. Okay, so no personal pronouns. After you write out your procedures, then you actually go and do your experiment. Okay? And you write down all of your data. When you're done doing your experiment, you're going to write out your results. Okay? Your results go under the title results. Okay? And your results are going to have a couple different things in them. First off, you need to have a paragraph that describes what happened in the experiment. And you should make sure that you give some data, okay, in your paragraph. Again, this is a paragraph, guys. It's not 1 or 2 sentences. It should be 5 to 7 sentences describing what happened. Now, there are 2 types of observations that you can make or results that you can get. There are something called qualitative observations, and those are observations where you look at something and you see if it's changed color or shape or texture, or it's gotten bigger or gotten smaller, but you don't actually measure anything. Okay? So there's no numbers involved in a qualitative observation. Qualitative stands for quality, so you're looking at qualities of the thing. There's no numbers. Okay? If you're doing a qualitative observation, then you're going to have your paragraph and you're going to draw some drawings or illustrations that show what happened in your experiment. Okay? And that's pretty much it, because again, you have no numbers, so you can't have a data table or a graph. You're just going to have your paragraph and you're going to have a drawing and illustrations. Now, if you're doing an experiment that has quantitative data or observations, and quantitative, guys, is long for the word quantity. Okay, so you're basically measuring things. You're getting numbers. You're measuring the distance or the time, or you're measuring how hot something is. You're actually measuring with numbers. Then you're going to need to have your paragraph written about what happened, and you're going to need a data table and a graph to show your results. Your data table, guys, should have at least 3 trials, so you need to do your experiment at least 3 different times and have data for each time you did it. And guys, your data table should contain the unit in the title. So if you're measuring in millimeters, you need to have millimeters in the title for each column in your table. If you're measuring in temperature, then you should have degrees centigrade or degrees Fahrenheit in your title in the column of your table. If you're measuring time, then you should have in seconds in the title of your table. Okay? And then you're going to need, if you're doing quantitative observations or you're measuring things with numbers, you're going to need a graph. Remember, guys, your graph needs to have a title. Make sure the X and the Y axes are both labeled. And guys, make sure you're using the correct type of graph. And we'll talk about that in a little bit, which type of graph you need based on what you're doing. So here's my example of my results. My results paragraph: the rotocopter made of construction paper stayed in the air on average 1.3 seconds. The rotocopter made of printer paper stayed in the air on average of 2.0 seconds. And the rotocopter made of tissue paper stayed in the air on average 1.4 seconds. This describes what happened in my experiment, and it gives data or numbers. Okay, so that's what you're looking for your paragraph. Then, since I was measuring the time the rotocopter stayed in the air in seconds, I was doing a quantitative observation in my experiment. I have a data table and I would have a graph. Notice my data table has 3 trials, so I did the experiment 3 times for each type of paper. And I wrote in my title the unit. So here, trial 1 is in seconds. Trial 2 is in seconds. Trial 3 is in seconds. And then I also took an average of this data. To get an average, if you don't know how to get an average, basically you add up all of your data and you divide by how many numbers you have. So for this first line for construction paper, when I dropped the rotocopter the first time, it landed in 1.2 seconds. When I dropped it the second time, it landed in 1.3 seconds. When I dropped it the third time, it landed in 1.4 seconds. I add those numbers up and divide by 3, and I get my average is actually 1.3 seconds. Notice, guys, I didn't write seconds down here. You don't have to as long as you have in seconds or in whatever unit you're doing up here in the title. Okay? And finally, your graph would go here. In this case, I'd probably use either a bar graph because I'm comparing papers, or I'd probably use a line graph. You could probably use either one. So how do you know what type of graph to make? Well, there's 3 main types of graph we use in science, graphs. We use bar graphs, line graphs, and histograms. A bar graph is when you're comparing things or when you're comparing categories of things, then you would use a bar graph. So for example, let's say I went out and asked everybody which football team they like the best. And I basically took a survey and then I wanted to create a graph to show my results. In that case, I would use a bar graph. I would put the names of the football teams at the bottom of the graph, and I would make a bar for each football team showing how many people voted for that football team. That would be a bar graph. Now, if I'm measuring things, if I'm using continuous data, if I have data that I can count, so for instance, if I'm measuring how many seconds it takes for something to happen, or I'm measuring the temperature that something boils at, or I'm measuring the distance that something travels. If I'm measuring something that you can actually count, so I can count 1 foot, 2 feet, 3 feet, 4 feet, 5 feet, 6 feet, or I can count 10 degrees, 20 degrees, 30 degrees, 40 degrees, or I can count it took 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. If you're doing something that you can count sequentially, then you're going to use a line graph. Okay? And a line graph basically has a line that connects all of that data. Finally, if I'm measuring something that has ranges in it of data, then I would use a histogram. A histogram, guys, if you've never seen one, is like a bar chart, only each bar goes for a range of data. The best example I can give you is ages. For instance, let's say I did a survey of 100 people, and they were all different ages. Okay? And I wanted to know how many people between the ages of 0 and 5 years old chew gum. Okay? And then I wanted to know, okay, how many people between the ages of 6 and 10 years old chew gum? How many people between the ages of 10 and 15 years old chew gum? I would basically make a bar chart, but each bar would go across a range of years, 0 to 5, 6 to 10. I'd have 1 bar for 0 to 5. I'd have 1 bar for 6 to 10. I'd have 1 bar for 10 to 15. Okay? So it would be a range of data. That's a histogram. If you're ever confused about what type of graph to use or you're not sure how to make one of these graphs, guys, come see me in class when you're doing your lab. I will be happy to explain it to you. I will be happy to walk you through it. I will be happy to show you if you ever get confused. Please don't think that just because I've told you about these 3 types of graphs on this video that you cannot come ask me about them. I am readily available for you to ask me. And if you're not sure if your graph is right, or if you've made your graph and you think it's right but you want to double check to make absolutely sure, please come show me your graphs and I will be happy to let you know ahead of time if there's anything wrong with it so that you can go back and fix it and get full points for your graph. Okay? Also, guys, later on I will try to make a video about graphing all by itself, okay, to help you out. But again, please come see me if you have any questions or any trouble. Finally, let's see here, after you figure out what type of graph you're going to use, you put your graph into your results. The last thing you need for a lab report is you need a conclusion. Okay? Your conclusion has to have these 6 things in it. Okay? So you're going to want to write these down. And if you ever get confused, come back and look at the video. Or if you're not sure, come ask me. But you need to have these 6 things in your conclusion. You need to restate your hypothesis, which means tell your hypothesis again. You need to tell if your hypothesis was right or wrong. You need to summarize what happened in your experiment. You need to give the data that proves that your hypothesis was either right or wrong. You need to tell any sources of error. And guys, a source of error is basically any mistakes that you made or that anyone made during your experiment that may have resulted in unreliable results or may have affected your results. So if you make any mistake at all, or if you think you might have even come close to making a mistake, you're going to list that in your sources of error. And finally, what would you change if you had to do the experiment again? Okay. Here's my example conclusion for the rotocopter experiment. And I'll basically walk you through each part. First, I restate my hypothesis. So I say, my hypothesis was that the rotocopter made with printer paper would stay in the air the longest. Boom, I just said my hypothesis again. I reminded everybody. Next, I'm going to tell if I was right or wrong. My hypothesis was proven to be correct. Next, I'm going to summarize what happened in my experiment. I'm going to use data in my summary. So I say, during the experiment, I made 3 different rotocopters. One out of printer paper, one out of construction paper, and one out of tissue paper. I then dropped them from a height of 5 feet and timed how long it took them to hit the ground. I did 3 trials for each rotocopter. Okay, that's where I actually summarized my experiment. Next, I'm going to give the data that proves that my hypothesis in this case was right. Okay? Here I say my results showed that the tissue paper copter on average stayed in the air 1.4 seconds. The construction paper copter stayed in the air on average 1.3 seconds. And the printer paper copter stayed in the air on average for 2.0 seconds. Boom, I just told the data that proves that I'm right, because here 2.0 seconds is the longest, and that's how long the printer paper stayed in the air. So that proves that I'm right. Now guys, if I was wrong, I would give the data that proved that I was wrong, and that's okay too. Next, I'm going to tell mistakes I made. One of the mistakes I may have made is that I may have started the timer too early or too late due to my reflexes. Also, the construction paper rotocopter hit the table when it fell during one of my trials. So those are the mistakes that I made, that's step 5, that actually may have messed up my experiment or caused my results to be different than what they would have been if I hadn't made those mistakes. And finally, last sentence here, I'm going to tell what I would do differently next time. Next time I do this experiment, I would like to change the length of the wings on the rotocopter and see if that makes a difference. Notice my conclusion is very detailed. It is at least one big paragraph long, 5 to 7 sentences, and it has all 6 of these things in it. Again, write these 6 steps down, and if you ever need an example, you can come back to the video and read this one as an example. Okay? Or you can write the example down if you want. It's up to you. Again, if you ever get stuck, if you want me to check your conclusion before you turn your paper in, I'll be happy to do that for you. Just let me know. Last but not least, I wanted to give you a page that shows the whole lab report all put together. Okay? So I have my title up here. I have the question, the hypothesis, the variables, the materials, the procedures. I have my results paragraph. Guys, it was too big to put on here, but right here is where your data table would go. Your data table does need to be here. It was just too big for me to fit it onto the slide. So this is where your data table would be. Again, you need to have your graph here, okay, under graph. This is where your graph would be. Again, I couldn't fit it on the slide, but you would put your graph here. And then your conclusion. So when you get done, your lab report would look like this. Most lab reports, if they are typed and if they have the data table and the graph inserted into them, are about 2 pages long usually. Most lab reports, if they're written out, can be anywhere from 3 to 4 pages long. Guys, I'm not so worried about how long the report is, because let's face it, some of you write very small and some of you write much larger. Okay? So I'm not concerned so much about how many pages the report is. What I am concerned with is that you have all of these things in your report and they are all very well written. Okay? So as long as you have them in there and they are all well written, or your data table is well done, your graph is well done, everything's well written, it doesn't matter to me how long it is, because again, some people write smaller, some people write bigger, some people like to type it, some people type it double spaced, some people type it single spaced. I don't care how long it is, but it needs to have all of this stuff in it, and it needs to be really, really well written and detailed and correct. Okay? That's pretty much the end of this video. Feel free to come back and review the video as you're writing lab reports. And again, please come see me in class if you have any questions at all, or if you're confused at all, or if you want me to check any of your work before you turn it in. Have a nice night.